Hi guys, so in this video we are going to look at a problem where we have to find the equilibrium index of the array. So we have been given an array A of size n and we have to find the equilibrium index of the array. So what is the equilibrium index? It is such an index where the elements to the left of that index, the sum of those elements is equal to the sum of all the elements which lies to the right of that element. So we can take an example. Let's try this element. The sum to the left of this is 2 minus 7 plus 3, and this is equal to minus 2, and sum of all the elements to the right is 1 plus 5 minus 8, and that is again minus 2. So this is a equilibrium index of the array. So there can be many number of equilibrium indices in the array, so we have to find just one, the first one from the left. So let's look at a very basic way to solve this problem. So what can be done? Like, so first of all, this element can't be equilibrium index because there is nothing to the left of this index 0. And similarly, to the right of the last index, there's nothing. There's nothing here, this side. So these two can't be our equilibrium indices at all. So we just need to check these elements starting from index 1 up to the second last element of the array. So what we can do, we can start with the first index, that is the index 1, and we can calculate the sum to the left of this, and we can calculate sum to the right of this. And if the sum on the left matches with the sum on the right, then this is the equilibrium index and we will return it. If we don't find it, then we will move to our next index, this index, and we will do the same. We'll find the sum starting from 0th index to up to here, and similarly we'll find the sum up from this point to the end point, and we'll compare. We will keep doing this for all the indices. We'll do the same. So if we do this, so what would be the time complexity? Because we are doing this for n elements, so we have a factor of n. And for every index, we are calculating the sum on the left and the sum on the right. That is again of the order of n. So this becomes n times n. Time complexity of the solution would be order of n square. Definitely not a good solution. So let's look at some better solution. So we have to see what is the major factor which is consuming most of our time. So this is true that we have to iterate to all the indices, that is unavoidable. The thing which is taking more time is that we have to calculate the sum to the left and sum to the right of every index. Say for this index, we have to calculate the sum on the left and the right. And this is taking order of n time. As of now, this is taking order of n time. If we somehow reduce this order of n time, then we can optimize the solution. And so prefix sum is one such tool we can use to calculate the sum in an array in order of sum in a range in order of one time. So maybe we can employ prefix sum here. So let's try to make a prefix sum array here. The prefix sum at this is 2, at this place 2 plus minus 7, that is minus 5. Here it becomes minus 2, here becomes minus 4, it becomes minus 3, here it becomes 2, here it becomes minus of 6. So we have generated the prefix sum array, and suppose we want to calculate the prefix sum at this particular index. 2. Then the sum to the left, we want some of these elements. This can be given by sum to the left of this index. This can be given by prefix sum at index 1. So sum to left of I, left of 2 is given by prefix sum at index 2 minus 1. That is prefix sum at 1. This is which is minus of 5. And sum to the right of 2. So what we need to do for the right elements, we have to find sum of all the elements. And we know prefix sum value at the last index give the sum of all the elements. That minus 6 is sum of all the elements starting from 0 up to the last index. So if we deduct these elements, sum of these elements from the total, that this is the total, then we will get this anyway. We will get these elements. That is, we deduct total sum from total sum. These values sum up to 0 to 2. We'll get some of these elements. Sum of 3 to 6. Total sum is given by prefix sum of last element. And sum of 0 to 2 is given by prefix sum of 2. So we get the sum this way. Prefix sum of last element, that is 6, minus prefix sum of 2. So given by minus 6. And prefix sum of 2 is minus 2. This is minus 4. So now we have the formula for calculating sum of the left and sum of the right as well. And if we keep doing this for all the elements from left, for all the elements starting from 0 to, not 0, starting from index 1 to the second last index, we'll find the equilibrium index if there is any. So let us now look at the code. So we have given an array A of size n. We have to prevent the prefix sum array, so we'll need order of an array. And for the first step, we'll create the prefix sum array. For that, we will initialize the 0th element, prefix sum by the first element of the array. We'll run a for loop starting from index 1 up to the last index, and for every index we'll do this. Prefix sum at index I is prefix sum of I minus 1 plus the current element of the array. So this way we generate the prefix sum. And the second step is finding the equilibrium index. Find EQ index. Let's name the function as find EQ index. The return type is going to be an integer. We will receive an integer array A, and we will pass the prefix sum array as well. after calculating the prefix sum of the array. And what we gonna do, we will run a for loop from 1 to saying last element of the array. Sum left is given by prefix sum of I minus 1, and sum right is given by prefix sum of the last element minus prefix sum of the current element. If sum left double is equal to sum right, we will return that particular index I. If we do not find any equivalent index, and we can turn some value, say minus 1. The time complexity of this code is order of n, as we're running from I is equal to 1 to up to last element. So order of n code, and this is also order of n. So overall time complexity of this solution is order of n plus n, which is order of n. Space complexity, we have used extra array for calculating the prefix sum, so it is order of n as well. So that is all for today. Thanks for watching.